quick tutorial on how to use the official Rust AWS SDK to list, upload, and download from an Amazon S3 bucket. So the setup is we have an S3 bucket, a demo one, and we have some files. We're going to add our dependencies. So first, we're going to use Tokyo for all of the async execution. Then on the file side, we're going to use Tokyo Stream, and we're going to see why later, but that will allow us to stream the bytes array to the file system without loading everything in memory. So it's very important. We're also going to use MIME-guess to get the content type of the content. So that is pretty important because otherwise you can get into some corner cases with S3 and CDN and so on if you don't upload the correct MIME type. And then on the AWS libs, we're going to use two crates, the config and the AWS S3. And usually the numbers are paired. Make sure you get the latest numbers. This one is the one that I'm getting at as of February 2022, but they are increasing it quite a bit until they reach the 1.0. And then the last one is going to be the anyhow. So I like to use anyhow for either unit testing or for exploration, which is what we're going to do today. In production code, we like to use this error, which is more structured, and especially for libs, you don't want to expose anyhow outside of your crate. And then we're going to have our downloads folder, which has nothing for now. And that is a to upload, which basically match what we have in our S3 demo bucket. Now we can go and focus on our main.rs. We can close the sidebar, and we're going to do our terminal and cargo run to make sure that everything compiles and everything is nice. And we always like to do our cargo watch -q -c -x and run -q for quiet again. So that will make everything very quiet and we just see the result. We can hide the terminal for now. So first we're going to allow the unused. That will silence the warnings for a little bit, and then later we can comment it out to clean up the code. So then one thing that we're going to use just for the exploration is going to be the anyhow. Then we're going to do our constants, and the two first ones that we're going to do is the environment variable name for the ID and the secret. The key here is never ever store secret and ID in the code. This will always come back and bite you. And those are just the name. You could use the default AWS names, but in this example, we're going to show how you can do it if you have your custom name. Then you have your bucket name. So obviously that would probably be dynamic, but here we're going to hardcode it. And finally, we need to drag along the regions to make sure that everything fits well in the AWS world. And so for now, we're just going to hardcode it. Next, we're going to do our Tokyo main. Make sure that we put the main async. We're going to return our first result anyhow, which will be a void. This means that we return a OK void. We're going to close the constants. So the first step you need to do is to create a client. And the way we're going to create a client is we're going to create a method, fn, get AWS client, and that will take a region. It can take more things, but for now, that is going to be the pattern, and that will return anyhow result of client. We're going to make it to do right now, such as we don't see compiles error. This client is we're going to import it. So now if we focus on this function, the first thing that we're going to do is get the ID and the secret from the environment variable. And so we have our environment variable names, and we're going to try to get it. And if not, we're going to call the context from anyhow, which will allow us to give some message. And then we do the question mark. So that will stop early, will return early. That's the whole point of the question mark. We import the env. Now the next step is to create the AWS credential. And for that, we're going to use the credential new from AWS S3. We're going to give our key ID that we had above, our key secret that we have above, and those are a couple of optionals that we don't need. And last, we say loaded from custom environment. And that is just a string, a description a little bit of how the credential was loaded. And it can be anything you want. So next, we're going to build the AWS client. And the way you do that is first, you need to have a region. And we're going to use a region object. There's many ways of doing it, but that is probably the simplest way. And we're going to give our regions that we had above to string. And then the next one, we use a conf builder. And so I strongly recommend here to not call the builder directly, but to have the config and import the appropriate config, which is this one. And then you can do a builder like that. Because inside AWS SDK, there's a lot of builders, so it can get very confusing very fast. We're creating a new builder, and we're going to give the region that we had above. And then our credentials, the way we give it is with credential provider, and we can give the credentials that we had above. And to get the conf now, you just do a conf builder, build. So far, so good. And now the only thing remaining is very simple. We just need to do a build AWS client, and that will be a let client. And you use the associative function, which is going to be a from conf. And then we can return our client, and we can remove our to-do. So now if we close the function like this, we can do our let client, get AWS client with our region, a constant, and then question mark. You need to make sure that you export your key ID and key secret in the terminal, and then you should have the hello world, which means that that didn't fail. We can close the terminal, and now the next step is going to list the objects of a bucket. So we want to have a method like this, where the keys will be a vector of string, for example, and we'll have an API that says list keys, we'll give our client, our bucket name, and that will return a vector of string, for example. So let's implement this function. So it's going to be async, it's going to be our list keys. First, we get our clients as an argument. Second, we get our bucket name, and that will return a result, which is anyhow result, and a vector of string. So that is how we are going to design this function. And for now, we're going to do the to-do, which is going to allow us to not have an error while we are coding this function. So the way it works with the AWS APIs is the first thing you do is you build the AWS request. And the AWS SDK follows a builder pattern for many things. So what you do is client, we're going to do a list object, make sure to take the v2. And that is going to be basically a builder. And then we're going to have our prefix. That will probably be an argument later. But for now, we're going to hard code it. And then you give your bucket name like that. So that didn't execute anything. It's just you are building your request with a builder pattern. Now, the way that you execute it is with doing the request send, and that will be an async method. So you do the await with a question mark. When that is sent, what you want to do is collect the data. And so we're going to do a let keys. And the way it works is in the response, you have contents that you can unwrap or default. And the nice things about that is that it will not fail. It will always return. And what it returns, it's a reference of an array of objects. And if there were an error, that is where the error will have shown. And now, because our APIs takes a vector of string, what we can do is a let keys, so that it will be a shadow variable. So the keys here is of this type. And that will be a new variable, which happen to have the same name, that will hide this one, because we don't need it anymore. What we're going to do is we're going to iter, so the list of objects. We're going to do a filter map, because when we're going to get the object key is actually an option. So when it's none, we don't really care about it. But when there's something, we want to have the key. And to make sure that we're not taking the ownership of the key, we're going to do a as ref, and that will give us the key without giving us the ownership of the key. So it will be a reference of the string type. And finally, because that will be a reference of string, we're going to do a map. That will be our string. So that will be a reference of string like that. And we're just going to do a s to string. So basically, we're going to take ownership in the vector, because that is what we want. And we're going to collect it with the turbofish notation, vect, and we can let the compiler apply this one. And now, because we're returning a string, then it will know that that is a vector of string. So if we toggle the type, we can see that we have a vector of string. And then finally, rather to do the to-dos, we can return our keys. Press save, everything seems to compile. We can toggle off the types. And if we close this function, we go back to our main. We can comment this line, and then we can print the result this way, a little bit of formatting. And we'll take the keys, which is a vector of string, and we'll do a join on new line. We don't need that anymore. We show our terminal, we press save, and then that's it. We see our result. And if we go back to our S3, this is exactly what we have in this bucket. So that's pretty cool. Let's close the terminal. And now we're going to work on the file upload. So let's say that we want an API like this. So we are going to have our path, the files that we want to upload, our great main.rs, and then we'll have an API like this. We'll say upload, file. We're going to do the reference of the client, the bucket name, and our path. And then with the await question mark. So it's going to be async. So we're going to comment this function because we haven't done it yet. And we're going to write it. Okay, so let's write this function now. It's going to be async, fn, upload file, the client as a reference, the bucket name, and then our path that will represent the files that we want to upload. It's going to return the anyhow result. And for now, we are just going to return void. Obviously, in a full API, you might want to return the list that has been updated, uploaded, or if it already exists or so on. First, we're going to validate that the path exists. So we're going to do if path doesn't exist. Then we're going to do the bare, and that will just create a one-off error that will be returned. So path does not exist. And we're going to do a path display because the path is an object. And because it is OS strings that are not always Unicode, that is a way to return something that you can print. And then our key for now, and as you build more sophisticated code, you want to do some cleanup, but we are going to base it on the relative path that has been given. And path to str returns an option. So in this case, we want to make sure that if it's not a valid Unicode, we can just fail it. So the way we are going to do that is going to be with using the OK, which is going to make this option as an error in Enum now, or else. So if it's none, it becomes an error, and that allows us to create our own error. So we're going to create a closure that will return an error, and we're going to use the anyhow macro that just creates a one-off error. A very convenient way, and you don't break the pattern again. And since 158, we can do the cool path and the debug notation. And the trick is question mark after, because we want it to fail and return only if there's this error. And now when we toggle the type, we see that we have a valid str. So doing this way with a question mark allows us to avoid big if else everywhere, because anyway, by design, we want to say if the path is not valid, then the function returns early. So the next step is going to prepare the content that needs to be uploaded. The first thing is we need to have the byte stream, the byte array, to be uploaded to S3. And for that, we want to have a stream. We don't want to load everything in memory to upload it. That will be memory inefficient. So the way we are going to do that is by creating a byte stream. And that is an API of AWS-S3. And this associative function, which is from path. And we are going to give our path as a reference, because we are going to use it later. And that is async. So it won't read everything, but to prepare it, it has to be async. So we do the await and the question mark. And the second information that we want is a content type. That is not required, but if you forget it, it can create problem later on when you use CDN or so on. So I will strongly advise to make it explicit from the get-go. So we're going to use our MIME guess that we put in our cargo to ML. There's an API that says from path. We give our path as a reference. And then you can call the function, which is a first or octet streams, which means that if it finds it, it's going to return the right content type. Otherwise, it's going to default to octet stream. And then we do a toString because we'll need to on this one. And now we are ready to build our request. So our request will be our client, will be the put object. So that will be our new builder to build this upload request. Our bucket will be bucket name, no surprise. Our key is a key that we define above. And again, in production code, you will probably clean it a little bit and make sure that is relative to some folders or so on. And then the body, that is a body that we had done above. It's just that it's a stream that is ready to be streamed. And then finally, we're going to put our content type. And now that we have that, we can execute the query. And that is the same as before. Request, send, and await question mark. We can do our OK. It will just finish executing the request send, and then it will return OK. Now that we have that, we can go back above. And in our main function, we're going to uncomment this file. And we are going to do a println, upload a file, and we can do the path display. it will format the path string correctly to be printed. Now, if we go back to our Amazon, we're going to press refresh to make sure that we have the correct data. Here we see that we don't have our source main. And now if we go back in our source code, toggle the terminal, press save, that we do our list, that will do our upload. And now if we go back to our AWS, we're going to refresh it. And then we have our source. Click on it, we have our main. And that's it. We have done a very simple upload, and it's actually streaming the data. So if we were going to upload a big video, 10 gig video, it will work exactly the same. So now we're going to do the download. So if we look at our files, we have a .test data, which is our root test folder. And inside we have an empty download folder. And that is where we are going to download our files. Let's close this. And so what we want is to have our dir, our download directory, which is going to be a path, new, our test data downloads folder. The keys that we are going to want to download is going to be the videos key 02. And then the API will be something like that. Download, file, the client, the bucket name, our keys that we have above, and our download folder. So we're going to comment this one out because it's not written yet. We're going to hide the terminal. And now we can write this function. The function name will be download file. We take our client, our bucket name, our key, the directory. We're going to return void as well. And right now we're putting to do, such as we can write it without compile errors. First, we're going to validate that our directory is actually a directory, so that it exists. And otherwise, we're going to do a bail, so that will just return an error, a one-off error, with this message. So that is from anyhow. It's very convenient when we do exploration. So now what we want is to make sure that we're going to create the parent dirs, because that could be a subfolder somewhere. So for that, we're going to get the parent dir of the file path, but the parent function return actually an option of path. So sometimes this might not be a folder behind. In this case, we know that there is one because there is this dir, but we want to have our code bulletproof. So what we're going to do is to have a OK, which is going to take the option and making it as a result. And we say or else, meaning that before, if it was a none, we're going to return an error object. And that is what this anyhow macro does, create an error object that will be returned. And the trick is that at the end, do not forget to put the question mark, such as you return early. So now the last step is to make sure that if the parent dir does not exist, we need to do a create dir all. We can take it from standard FS, we don't need to make it async, and that will take our parent dir. Now that we did the prep, we can build the AWS request. Very simple. Let our request, the client, that will be a get object. The bucket will be our bucket name. And then the key will be the key that is passed to the function. This is just a builder, doesn't execute anything yet. We're going to execute it. Same pattern as anything else. So now what we want is to stream the data to the file system. So first we're going to get the data as a batch stream from the resource body. And that will need to be mutable because we're going to get the data. Then we're going to create a file with a file, and we can just take a standard file. We don't need to be async when it's local files. You can, but not really needed. And we're going to do a create file path and the question mark to make sure that we get a file. Next, we're going to create our buff writer to write into the file. So we're going to do a mute buff writer, and that the struct will be a buff writer. We do a new and file. So that will create a buff writer, a file that we're going to use to write to the file. So the only thing that we need to do is iterate through the data stream and write it to our buff writer. So to do that, we're going to do a while let sum of bytes, meaning that the first time it will return none, then the while will stop, and then we're going to do a data, we do a try, next. And that comes from our Tokyo stream ext. So that is why we had the Tokyo stream, because we need to have this straight implementation. Now that we have that, the reading of the data stream is going to be non-blocking. So we're going to do a await question mark. And now we can write into our buff writer. That is a buff writer which is not async. Doesn't really need to be again on the local file, but you can get a buff writer async from Tokyo if you really want to write async to your file system. And that we give our bytes that we just read from the data. Question mark, if it fails, we want to return early. And then to have the write, we need to import our write trait. That is where the implementation is. And finally, we just need to do our buff writer flush. If you were using the Tokyo async buff writer, you will obviously do a flush await question mark. And then at the end, we can return our void. We're going to close this function, go back to our main, and now we can say download file. We can see our download folder is empty. We're going to call our download file. Obviously, we want to do the await question mark. We're going to have our print. We're going to press save. And now if we go, we see the upload, we see the download, and we see we created the video folder and then the video. And then if we click on the video, we have a cool skiing video just for us. And that's it. That will be it for today. Hope you liked it. Until next one, happy coding.